Hello, everyone. Today we're going to continue with our study of isosceles and equilateral triangles. We're going to see how we can use the facts we learned there in proofs to help us out. We have three proofs to do that we're going to do today in class. The fourth one on here we're going to do as our next day's warm up. So let's get started with number one. So number one tells me that TR is congruent to TS. So since we have multiple lines here, I like to color code it. So TR is congruent to TS. Then we also know that TM is congruent to TN. So we know those two facts. So that's our givens. And then what we're trying to prove is that triangle RMS, so RMS is green, is congruent to triangle SNR. So the first thing I notice when I outline that is that RS is part of both. So I'm going to say that RS is congruent to RS, and that's reflexive. And that really has nothing to do with my givens. That's just what I notice when I outline the two triangles. So that gives me one side. So now when I'm trying to get that green and that yellow, I need to get something else. I need to get more sides, angles, whatever. So now I'm going to focus back on my givens. So my first given that I can't really see here anymore is that TR is congruent to TS. Well, those are two sides in a triangle. And what do I know when two sides in a triangle are congruent? That the angles opposite them are congruent. And the angle TRS is part of my green triangle, and the angle TSR is part of my yellow triangle. And therefore, and because they're across from opposite sides, I know those two angles are congruent. So that's going to be my next step, which is angle TRS is congruent to angle TSR. Because in a triangle, you must say in a triangle, angles opposite congruent sides are congruent. So now I have a side and an angle. So now also looking at emphasizing those two sides I also know TM is congruent to TN. So if I look at that blue and the purple, if I subtract those, I get the green, which is the side of my triangle. And if I do the same thing on the other side, I get yellow, which is the side of my triangle. So I'm going to do that subtraction. So I'm going to say that TR minus TM is equal to TS minus TN. And that's subtraction. And then that tells me that MR is congruent to NS with substitution. And then I have my green and my yellow triangles by side, angle, side. So that's triangle RMS is congruent to triangle SNR by side, angle, side. Okay, next proof. So I'm going to get this one started, and then I want you to think about it and try to do it, and then so pause the video and then come back and check. So we know that AE is congruent to ED. So there's my first given. And I know that AB, so I'm going to switch colors here, is congruent to CD. now what I'm trying to prove is I'm trying to prove that AEC, which is this larger triangle here, is congruent to triangle DEB. I'm trying to prove that yellow is congruent to that green. So I want you to pause and think about it, and then come back and I'll go through it. All right. So when I look at this triangle, the first thing I notice is that in triangle AED, I have two sides that are congruent. That means the angles opposite those two sides are congruent. So angle A is congruent to angle D, which happen to be angles in my triangle. So that's good. So I'm going to say angle A is congruent to angle D. And that's because in a triangle, angles opposite congruent sides are congruent. I forget to write given up here. So in my yellow triangle, compared to my green triangle, I now have a side and an angle, a side and an angle. So now to prove them congruent, I need either another side or another angle. If I'm looking for another side, that other side that I need would need to be AC and BD because it has to be side angle side. Well, looking down there at A, B, and CD, or A, B, C, and BD, I notice that there's an overlap here of BC. And I know that I have the two little parts congruent. So that says to me, if I add those two parts together, I have the longer line. So I'm going to do that. So I start by saying BC is congruent to BC. And I need to say that because I need two parts to add together. And right now I only have one, but that's reflexive. So then I can say AB plus BC is equal to BC plus CD, and that's addition. And then I know that AC is congruent to BD by substitution. And then lastly, I have my triangles. So I know triangle AEC is congruent to triangle DEB, and that's by side angle side. Okay, so number 3, I want you to start it from the beginning, try it yourself, then come back and we'll go over it. So pause and try it. Okay, so what I want to prove is I'm going to try to prove ABC is an isosceles triangle. So in order for it to be an isosceles triangle, I need two sides congruent. I currently know angle 3 is congruent to angle 4. Well, when I look at this, I see that 1 and 3 are a linear pair. And I see that 2 and 4 are a linear pair. So I'm going to say that angle 1 and angle 3 are supplementary. And angle 2 and angle 4 are supplementary. Linear pairs are supplementary. Remember, linear pairs are when they make a straight line. So now, knowing those are supplementary, we got to think back to that other theorem. I know that 3 and 4 are congruent, so we learned a theorem that said angle 1 has to be congruent to angle 2 because supplements of congruent angles are congruent. So now I know 1 is congruent to 2. Well, now I know that 1 and 2 are in a triangle, so that means that AB is congruent to AC because in a triangle, remember you must have that, sides opposite congruent angles are congruent. And therefore, triangle ABC is isosceles. Definition of isosceles. So again, if you have any questions, please let me know in the comments. Tomorrow or the next day we have class, we will do number 4.